Yeah. What are the elementary transformation? You may not recall exact transformations. So how the elementary transformations are classified first? Yes, anyone?
Row transformation and column transformation.
Rearrangement of two
Okay,
rows.
first one Prathamesh says that the elementary transformations are further classified as a row transformation and column transformation, correct? So first recall what are the row transformation. In the same way, we can define or we can extend the concept to the column transformation. Okay, Shivani Patil, you want to say something?
Same sir, row and column
Okay,
transformation.
what are the particularly row transformations? So while finding inverse of a matrix, what we did in 12th, recall, and we can generalize that.
Multiplication of two rows, the addition of two rows.
Okay, Omkar Bosle says
Swapping
that,
two rows.
okay, just I will brief about this. After that, we can take answers. Multiplication of two rows. Suppose rows are denoted by R1, R2, R3 like this. So whether you have applied such type of transformation R1 multiplied by R2, something answer I have got in the chat box that I will take afterwards. Say yes or no. Whether you have applied such type of transformation.
Yes.
Further, R1 multiplied by R2 or R3 multiplied by R4. You are multiplying any two rows. What about others?
Swapping two rows.
Can you repeat?
Swapping of two rows.
Swapping of two rows means what exactly? In terms of mathematical terms. What about this one, first one? One answer came that R1 into R2. Such type of transformation is there. 49 students are, but very few students are talking. Huh? Reply quickly. So while finding the inverse, I think you did like this. A into A inverse is equal to I, and you are applying elementary transformation on these two matrices, and you are finding this matrix A. So while finding that inverse of a matrix, such type of transformation you are applied. Just you have to say yes or no. If you applied, then you say yes. If no, then say no. Yes. Yes, once again repeat, please. Quickly reply. Otherwise, I will take a name. Tanmay Patil, what is your opinion? Krishna, multiplication of any row or column by non-zero scalar quantity. So this is an elementary transformation. Suppose first I will recall for the column. Ri is the row. So any row you can multiply by a non-zero scalar where k is not equal to 0. Okay, this is a transformation. So first here I will write. So multiply the ith row by a non-zero scalar, and that transformation can be denoted as non-zero scalar k. So that can be denoted as, suppose Ri, and I am using arrow. That means what I am doing here, I am changing ith row by k into Ri, or simply you can write k into Ri. That means you are changing ith row by a k into Ri, where k is not equal to 0. Okay, correct. Next one. If your mic is not working, you can write your answer in the chat box. Quick. What are the elementary transformation apart from this?
We can add the rows.
Okay, we can add the row. I will take afterwards that. Add rows. Next one. R1 plus R2, R1 minus R3 like that. That is possible. Further, suppose I will give you an example. Huh? So what happens? You are finding inverse of this matrix. This is a 2, this is a 1, this is 0, 0, 1, 2, 0, 1, 3. What is our target? this matrix, suppose you want to reduce to the identity matrix, that means 1 0 0 0 1 0 0 0 1. So what is your first transformation for this matrix?
R2 equal to 2R2 minus R1.
My first target is, afterwards I will reduce 0. My first target is to obtain this element as a 1. Then what you will do? Unmute anyone.
R1
R2 minus
is turned
R1.
to R1 minus R2.
Okay, what once again repeat? R2
R1
R1.
R1 is equals to R1 minus R2.
Okay, R1 you are changing to R1 minus R2. What happens? That becomes minus 1. Then next,
R1 minus 2R1.
R1 minus 2R1, it becomes 0 na. This element, easy steps you are not recalling. This element I have to reduce to 0. And suppose instead of
R1 is changed to R1 minus R2.
no. Now see this element I will give 3 by 4 like this. Then what you will do? You are not getting exactly. What is the first elementary transformation? Purposefully I have given. Any other? If you think on these two elements.
Sir, if we change the rows,
Yes, that is the first basic elementary transformation. We can change any 2 rows or any 2 columns as per our requirement. Okay, that is the first transformation. First transformation of interchange of ith row and jth row. Ith row and jth row. And this transformation is denoted as either like this, Ri interchange to Rj or Rij. I am using second notations. Both notations I am doing first. Okay, this is the first elementary transformation. So similarly, we can extend the concept to the column. When you are saying interchange of any 2 rows as per our requirement, at the same time, we can interchange any 2 columns. The second property says that multiply any row by a non-zero scalar. That means multiply any column by a non-zero scalar. That parallelly you can write. Okay. And third one, just to say that addition of, I will write addition of 2 rows, R1 plus R2. So I will generalize. Suppose just you told na 2 times. So that will generalize. You can multiply any row by a non-zero scalar and the resultant row you can add to the any row. So that transformation I will write as replace the ith row. Replace the ith row by k times the jth row by k times the jth row plus ith row. And this transformation can be denoted as you are changing that ith row by Ri plus k times Rj, or simply you can write Ri plus Rj. I am following the second notations, these notations. Okay, while solving examples, I will follow these notations. Okay, when I am writing like this, that means you are changing that ith row. Here I forgot to write k. K is there, multiplied by k. So these are the elementary transformation, and these elementary transformations, suppose first elementary transformation I will denote as a E1, second elementary transformation as a E2, third as a E3. So these are elementary transformation related to the row. In the same manner, you may write elementary transformation for column. So first one, you can interchange any 2 columns as per your requirement. You can multiply any column by a non-zero scalar where k is not equal to 0. And next one, Ci plus k times Cj. Okay. So as per your requirement, further you can define or you can consider the elementary transformation. Is there any doubt related to this?